Enthalpy. Enthalpy. It is used to quantify the heat flow into or out of a system in a process that occurs at constant pressure and we define enthalpy change delta H at products minus at reactants. So now delta H is heat given off or absorbed during a reaction at constant pressure. So now let's look at two of those examples and then you can find delta H of that system. So I'm going to go to next slide. Let's say in here we have methane CH4 gas, and when it combusts in presence of oxygen gas, and what happened? It produced CO2 gas. When it combusts, when it burns, it produces CO2 gas and 2 moles of H2O in liquid form, right? And so this is enthalpy I'm going to write. Now what happens whenever it's a combustion, heat given off by the system to the surrounding, because it's burning, right? So whenever that happens, delta H is negative and 890.4 kilojoules per mole when we measure. So when you see that, you can say at products is less than at reactants. So that means delta H is less than 0 whenever it's delta H, you can see negative sign. Combustion process, heat is given and it's by the system to the surrounding. So that way you can say yes, if it is exothermic, then delta H is negative. If it is exothermic, then it is negative. Delta H is negative. Now I'm trying to draw it here and see if we can try to compare and understand it. let's see if we have H2O liquid and we have H2O solid. When we convert from solid to liquid, H2O, ice to water, you provide heat, right? So what happened? Heat absorbed by the system. Heat absorbed by the system to the surroundings. So you can write that. And delta H is going to be positive. Why? I'm going to explain. You can see kilojoule per mole, 6.01 kilojoules per mole. In this case, H products is greater than H reactants. So that means delta H is greater than 0. So that's for endothermic. So for endothermic process, delta H is greater than 0. So you can say for exothermic and endothermic. And then we'll talk about how do we consider stoichiometric coefficient and how do we multiply to delta H in the equation.